right, I believe that we are live. So I just want to say good morning to Glenn and Evangeline, as well as Danielle, Hayden, and Jaden. Hope you all are having a great morning so far. You've arrived. It is your final day of virtual. We are planning to be back in the classroom on Monday morning at 8 o'clock. So I am looking forward to that. I won't be teaching math. I will take you guys back in history of the world. Hopefully you haven't gotten too accustomed to Mr. Smith, and look forward to being with you next week. Let's go ahead and start in a word of prayer, and we'll get right into our lesson for the day. Lord, we love you, and we thank you so much for the privilege and opportunity we have to be involved with Grace Christian School. Lord, we are so excited about our students coming back next week, but we do have this one day left, and I pray that you give wisdom to me as I teach, give these students clarity as they listen. I pray if they don't understand something that they'd reach out, and Lord, if I can go ahead and even answer questions that they may have before they have to ask it, well, that would be awesome, just by nature of the type of education we have right now. We love you, we thank you, in Jesus' name, amen. All right, so open your textbooks, page 116. Your homework last night was to do numbers 1 through 26, sharpening skills. 1 through 26, sharpening skills. I want to go through these. Number 1, page 116. Number 1, there are 16 fluid ounces in a pint. Number 2, there are 100 centiliters in a liter. Don't forget, here you're going from centi back to the unit, 1, 2. And if you start with 1, you're going to go, again, you're going from, and I should actually say you're starting with liters. I'm sorry, because you have 1 liter. So you're going over twice, so there's 100 centiliters there in number 2. Number 3, you're going from 1 kilometer, how many hectoliters? So you start at kiloliters here, and you're going from kiloliters to hectoliters, which is 1 to the right. If your number is 1, move your decimal 1 place to the right. You have 10 for number 3. Number 4, there are 5,280 feet in a mile. Number 5, you're going from 1 decameter to a meter. So if you're starting decameter and you're going to your unit meter, you're moving to the right once. And so if you start with 1, you move it to the right once. You're going to have 10 for number 5. Number 6, there are 4 quarts in a gallon. Number 7, there are 3 teaspoons in 1 tablespoon. Number 8, there are 100 milliliters in 1 deciliter. Again, you're starting with 1 here at the deciliter. It's 1 DL, and you're going over to the right to milliliters. And so because you're going to the right, you start with 1, and you move your decimal twice, you get 100. Number 9, there are 2 cups in 1 pint. Number 10, there are 100 liters in 1 hectoliter. Number 11, there are 36 inches in 1 yard. And number 12, there are 8 fluid ounces in 1 cup. Again, 8 fluid ounces in 1 cup. Number 13, don't forget when you're dividing, you have to invert the divisor, that means 7 2/9. When you turn that into an improper fraction, will actually be 9 times 7 is 63 plus 2 is 65 over 9 times 4 over 3. Cancel all that out. You should end up with 9 and 17 over 27. Number 14, everything cancels, and it ends up coming down to about 1/2. 1/2 for number 14. Number 15, don't forget when you're borrowing from that 7, you bring over a whole number fraction, which is 7 over 7. Minus 2 sevenths is going to equal 5 sevenths, and 6 minus 4 is 2. So 2 and 5 sevenths for number 15. Number 16, don't forget when we have an exclamation point after the end, what they want you to do is they want you to multiply all the numbers preceding 8. So we're going to take 1 times 2, and that equals 2 times 3 is 6, so on and so forth. And you're multiplying all those numbers consecutively. When you do that, you're going to come out to 40,320. Number 17, you do have to find a common denominator there. The common denominator is 18. And so once you add, number 17 is going to be 19 and 13 over 18, or 13/18. Number 18, don't forget to annex zeros when you're subtracting decimals. This should come out to 5.005. Number 19 is 16.72. Number 20, 10 times 10 times 10, by the way, is also like 10 times 10. This is what we're doing here. But you have 3 zeros there. It should equal 1,000 for number 20. Number 21, don't forget you should have 5 decimal places in your final answer. So that should be 2.87448. Number 22, you move your decimal over on 0.76 to after the 6, which means you're also going to move your decimal over to after the first 0. So it's really 630.04. divided by 0.76, and that's going to equal 8.29. 8.29. Number 23, you have 5 decimals, but you only have 3 numbers, so you do have to add some zeros there to the left, and you should have 0.00161. Number 24, dividing by 3/8, which means you're multiplying by 8/3. That equals 54 2/3 for number 24. Number 25, 500 feet is what percent of a mile? 500 feet is what percent of a mile? Well, you got to know how many feet are in a mile. 5,280. So you put 500 divided by 5,280. Cancel out your 2 zeros. You're left with 50 over 528, which reduces to 25 over 264, and approximately is about, to the whole number, 9%. 9%. Number 26, 280 liters is what percent of a kiloliter? How many liters are in a kiloliter? 1,000. Kilo means 1,000. And so 280 over 1,000, cancel out your last 2 zeros, 28 over 100. Of course, that's 28%. So hope you got those right. Again, we're not spending a lot of time on the homework, but if there is anything that you have questions on, what I would like for you to do is call or email us, and we'll set up a call. And then, of course, we'll be back Monday, so if you have any questions then, we can certainly try to address those in class. That'll be Mrs. Morrison at that point, but please make sure that if you have any questions, you get those answered. Don't go with those questions unanswered, because we want to make sure we're building on top of each other in each one of these lessons. All right, I want to review some concept cards here, okay? So let's make sure that we know these answers here, okay? So some of they're going to be all the way around, so we're going to go in no particular order. So make sure that you know what you're doing, okay? So you yell out the answer, and then I'll give it to you, okay? And I probably should turn this around. All right, here you go. You ready? And we begin. You shout out the answer, okay? And then I'll tell you what the answer is. Here we go. 100. 1,000. 1,000. Are you getting these? Make flashcards if you don't know them. I'm telling you to help you. 100. 10. 1,760. 5,280. 36. 3. 12, 10, 4, 8, 16. We're in our capacity measurements here. 8, 4, 2, 3, oops, sorry, 1,000, 1/100th, 1/10th, 100, 10, 1/1000th. Very good. All right. Hey, I'm going to give you one last opportunity, because it's Friday, and your parents may be in an extra good mood because this is the last day of virtual education. And if they are in a good mood, now's the time to ask them, hey, can I have, Mom and Dad, can I have candy if I beat Mr. McDonald on these questions? Maybe every 3 that you beat me on, you can get a piece of candy. But if they won't let you, that's okay. We'll reconvene in class on Monday, and we'll see what we can do about that. But here we go. We're going to start backwards from what we just did, and you go ahead and give me the answer and see if you can do it faster. I'm going to go fast on these, okay? See if you can beat me on these. Here we go. You ready? 1/1000th. 10. 100. 1/10. How you doing? Are you beating me? Okay. I'm doing it pretty fast, so here we go. 1/100th. 1,000. 3. 2. 2. 4. 8. Oh, you didn't even have a chance on that. Mr. McDonald was fast. Okay, 1 cup equals 8 fluid ounces. That one was a little, that one wasn't fair, I will admit, okay. 16. 8, 4, 10, 12, 3, 36, 5,280, 1,760, 10, 100, 1,000, 1,000, 100. All right, did you beat me at all? I kind of went slower there at the end, but there at the beginning I was going pretty fast. I hope your parents will let you have candy. If not, eat some extra chips at lunch, okay, for beating Mr. McDonald. Make sure you're familiar with those, okay? Make sure that you are memorizing those. Those are very important. And if you don't know them, make flashcards. Very good. That will help you out a great deal. At this time, if we were in class, we would go ahead and take quiz 10. You should have a copy of it in there in your packet. Please go ahead and have your proctor take care of that. Even right now in class, you can go ahead and push pause, take your quiz 10, and then take a picture of it and go ahead and send it to Mrs. Morrison, and she'll get that graded and returned to you on Monday. But if you need to take it at another time with your proctor, then go ahead and continue watching the video, and we'll move forward. Those of you that are watching, let's move on, and we are going to go to page 117 in our textbook. So turn to page 117. Page 117, we are looking today at measures of time. The definition of time is the measuring of the passing of events. How quickly did an event go? Have you ever been at an event and it just seemed to drag on? It was maybe so boring. Now, don't talk about this class like that, okay? I know some of you were thinking, oh, basic math with Mr. McDonald. No. That is not true. You cannot say that. But no, maybe some event where it just seems to drag on. And sometimes when we measure time, even though it may seem to drag on or an event may seem to go fast, it's still the same time because we have what we call standard measurements of time. The basic unit for time is the year. And we divide the year down into months. We can divide it down into days, into hours, or weeks into days, into hours, into minutes, into seconds. We can even go above a year. We can go into a decade, a score, a century, a millennium. We even have some specific ones called a leap year. We'll talk about that here in just a moment. So 1 year is the time that it takes to go around the sun. And for the earth to revolve around the sun. A month is the time it takes for the moon to revolve around the earth as well. A day is the earth rotating. So as the earth is going around the sun, revolving, it is also rotating on its axis. And it does this 365 times because it takes 24 hours to do it as it goes around the sun. So that's pretty interesting as well. 1 solar year, we won't learn this specifically, but 1 solar year is equal to 365 days, 5 hours, 48 minutes, and 46.05 seconds. Is that specific enough for you, detailed enough for you? But that is approximately 365 1/4 days, which leads to our leap year. 1 leap year equals 366 days. So 365 calendar days, 366 in the leap year. Now, you can find out what a leap year is by doing this. Take the last 2 digits of the year and divide by 4. If it is divisible by 4, you're good to go. That's a leap year. Now, if it ends in 00, the whole thing has to be divisible by 400, okay? So if we take the year 2000, that would be divisible by 400, so that was a leap year. It was also an election year. If we have, for instance, 2020, the last 2 numbers are 20, and that's divisible by 4. 20 divided by 4 is 5. So if it's divisible by 4, the last 2 digits, or if it ends in 2 zeros, if the whole year is divisible by 400, you've got yourself a leap year. And so that kind of helps you out, especially when doing word problems, to calculate what is a leap year and what is not. I want to show you, I've got a map here, or not a map, but just kind of a chart that will explain some of these to you. So let's go ahead and say with me, you may know these. I know 4th grade right now is doing them downstairs, and maybe even 3rd grade, but I think you guys know these, but let's go over them just in case as a recap. So here we go. Say I'm along. We'll do this chart twice through. Are you ready? And we begin. We're going to go ahead and start now. 60 seconds equals 1 minute. 60 minutes equals 1 hour. 24 hours equals 1 day. 7 days equals 1 week. About 52 weeks equals 1 year. 365 days equals 1 year. 366 days equals 1 leap year. 12 months equals 1 year. 10 years equals 1 decade. 20 years equals 1 score of years. 100 years equals 1 century. 1,000 years equals 1 millennium. Notice this verse. From the rising of the sun to the going down of the same, the Lord's name is to be praised. Guess what? The sun is always going to rise and the sun's always going to set. So we should always praise the name of the Lord. One more time. 60 seconds equals 1 minute. 60 minutes equals 1 hour. 24 hours equals 1 day. 7 days equals 1 week. About 52 weeks equals 1 year. 365 days equals 1 year. 366 days equals 1 leap year. 12 months equals 1 year. 10 years equals 1 decade. 20 years equals 1 score of years. 100 years equals 1 century. 1,000 years equals 1 millennium. You want to know those. Class, if you don't know those, you should make flashcards. That's right. Make sure you get flashcards made if you are not familiar with that chart. You'll also see on page 117 the yellow box. We're becoming familiar with yellow boxes. Yellow boxes mean memorize. Yellow boxes mean memorize. At this time, what I would like for you to do is just pause and read 6.6. So press pause and read section 6.6. Now that you push play, we are going to move into some examples I have on the board. There are 2 rules for converting in the English system. There are 2 rules. You remember what they are? First of all, we need to find out, are we going from large to small or are we going from small to large? And then we need to figure out what our conversion factor is, okay? If we're going from large to small, we multiply. That's correct. If we're going from small to large, we divide. Very good. And our conversion factor, by definition, is how many of the smaller units are in the larger unit, okay? So there's some help to you because as we go through these examples, you're still going to want to remember that. Now, we're not, unless it's a review question, we're not really going to be looking at King Henry dared you to drink chocolate milk today. We did in our homework, and we probably will. I think it may be one word problem, but that's just up there in case we need it. It's not really for our time. We're not going to use it for time yet, okay? Later on, we may use it for time. So let's look at example A. We're converting time here. Same rules as the English system. We're just using time, different measurements, okay? So we want to go from 48 months to how many years is 48 months? Well, first of all, which one's larger, a month or a year? The year is. So the year is larger and the month is smaller. So going from small to large. So if we're going from small to large, we divide. Very good. So what are we going to divide by? Well, we want to divide by how many ever the smaller is in the larger. Well, how many months are in a year, class? 12. So 48 divided by 12. Well, if you remember your 12 times tables, you know the answer to that. But just in case you don't, let's go ahead and reduce. Well, the greatest common factor is 12. So we would actually reduce by 12. Well, let's reduce by 2 to help you out. 24 divided by 6. And how many times does 6 go into 24? Of course, the answer is 4. So the answer is 4 years for letter A. Let's try letter B here. Same rules. We need to find out if we're going large to small or small to large. What's the conversion factor? And of course, is it reasonable in the conclusion? So, which one's larger, decade or year? A decade, right. So this one's larger, this one's smaller. So we're going from large to small, so we multiply. Excellent. Well, okay, so this is small. So how many years are in 1 decade? 10 years. Good job. So we need to take 5 times 10 equals what, class? 50 years. Very good. There's your answer. Was that pretty simple for you? Is measuring time pretty simple? Again, the only reason it's simple is because 3 lessons ago we learned how to convert English measure systems. And when you figure out if you go large to small multiply, small to large divide, what's my conversion factor and does it make sense? When you figure those things out, it's pretty simple from there on out. You just have to know the measurements, of course, right? So, with that in mind, let us go to some practice problems. We're on page 117. Let's go ahead and jump to number 1 through 9. So, say these along with me. I'm going to let you yell them out, and then I'll give you the answer, okay? Number 1, how many months in a year? 12. Number 2, how many days in a week? 7. Number 3, how many years in a century? 100. Number 4, how many days in a year? 365. Number 5, about how many weeks are in a year? I should have let you say that, but it's about 52, okay? There's about 52 weeks in a year. And by the way, don't put 52, put about 52, because it's not quite the exact same number there. Number 6, how many days are in a leap year? 366. Let's look at number 7. How many minutes are in 1 hour? 60 minutes. Great. Number 8, how many hours in a day? 24. Very good. Number 9, how many years in a millennium? 1,000. Excellent. Hopefully you're getting familiar with those if you don't already know them. Let's look at number 10, 11, and 12. Number each column from least to greatest. They've done some for you on number 10. They said that the least on number 10 is the second, and then the minute, and then the day. So all we have left is the month and the week. Which one's going to be number 4? That's right, the week is number 4, and then the largest one of all of that is the month, number 5. So you should have 1, 3, 2, 5, 4. So let's look at 11. We're comparing 5. We've got a year, a day, a century, a millennium, an hour. Which one of those is the smallest unit? I hope you said hour. So put a 1 beside hour. Okay, well, what's the next largest one? Is it a year, a day, a century, or millennium? Well, it's going to be a day, so you should put 2 by day. What's the next one? Year. Very good. The next one, century, that's 100 years. And the millennium, which was 1,000 years. So in order on number 11, you should have 3, 2, 4, 5, 1. 3, 2, 4, 5, 1. Pause the video for just a second and do number 12. All right, you should have, now push play because you're done with 12. Let's go over these. You should have on those 3, 1, 4, 2, 5. 3, 1, 4, 2, 5. Your second is the smallest, then the next is a year, then a leap year. Notice leap year is 1 day more than a year, so it is the larger one of the two. And then we go to a decade, which is 10 years, and then 20 years for the score of years for number 5. So again, number 12, 3, 1, 4, 2, 5. All right, we are going to do some conversions here on page 117, some conversions on page 117. We are converting from one to the other. So I'm going to set a couple of these up so that we can practice them. And I'm going to leave that up there, though we're not really going to need that for the measurement system, but I do want the rest of this chalkboard to be able to go over these accurately. So let's start down here, and we're going to start with number 13. I want to point something out to you. Number 13 says, how many days are in 7 weeks? Okay, I want to point something out, and be careful with this. We have often been going from some measurement to another measurement, and this is the one we're trying to figure out, okay? All they've done is inverted the sides. So we're going from, because we're going to this, we're going from weeks to days, okay? So which one's larger, week or days? A week, very good. So this is the larger one, this is the smaller one. So we're starting with 7 weeks and going to days, so we're going from large to small, and if we're going from large to small, we multiply. That's exactly correct. Well, the smaller one is days. How many days are in a week? 7. So we're going to take 7 times 7. And class, the answer is, good job, 49 days. 49 days. Let's go to number 14. Number 14 says, how many weeks equals 35 days? Well, we're doing the exact same thing here, except it's inverted. Which one's larger, week or days? Week, that's right. So here's your larger, here's your smaller. But again, we're starting here and going here, so we're starting with small and going to large. You start small, go large, you divide, that's right. We're going to divide by the conversion factor. So 35 divided by how many days in a week? 7. What's 35 divided by 7, class? That's right, 5. So 5 weeks equals 35 days. Let's look at number 15. Number 15 says, how many years equals 9 months? How many years equals 9 months? Again, which one's larger, year or month? A year. So you have large here and you have small here. And remember, we're going this way, so we go from small to large. If I'm going from small to large, I divide. That's right. How many months, the smaller one, are in the year, the larger one? 12. So 9 divided by 12. Well, let's go ahead and reduce. What's the common factor of 9 and 12? 3 is the largest one. So 9 divided by 3 is 3, and 12 divided by 3 is 4. So you have 3/4 of a year. Are you getting these? All right, I hope you are. I hope they're coming easy to you as you understand the principle. And once you understand the principle, you can kind of, I can't say fly through them, but you can do a good job of getting through them. Let's look at number 16. 16 says, how many centuries equal 230 years? Okay, well, once again, we're going from years to centuries. Which one's larger? Centuries. So we're going from small to large, so we divide. Very good. So 230 divided by, how many smaller and the larger? How many years in a century? 100. Okay, so if there's 230 divided by 100, we can go ahead and cancel that out, and we're left with 23 divided by 10. Well, you may remember if we're dividing by 10, we're moving the decimal to the left. So we have 23, and move your decimal to the left once, you have 2.3 centuries. And again, you could also divide it this way. It's a little bit longer of a way, but 10 goes into 23 2 times. Times 10 is 20. Bring down your 3. Annex a 0 here. 10 goes into 30 3 times. The answer will still be the same, no matter which way you do that. Let's look at number 17. Number 17 says, how many decades equals 30 years? Again, let us, which one are we going, or which one we start with? We're starting with years, larger, smaller than decades. That's smaller. So we're going from small to large, so we divide. That's right. How many years are in a decade? 10. So 30 divided by 10, and 3 divided by 1 is 3. You did it. Let's do number 18. Number 18 says, how many days equals 1/2, and this is a leap year. Okay, well, which one's larger, a leap year or a day? Well, certainly the leap year, so we have large and we have small. So we're going from large to small. Large to small, we multiply, that's right. So we're going to take 1/2, and how many days are in a leap year? That's right, 366, not 365. I can actually cancel this out. That's a 1. 2 goes into 3 once with 1 left over. 2 goes into 16 8 times. 2 goes into 6 3. So I actually have 183 days in 1/2 of a leap year. All right, let's do number 19 together. Number 19 says, how many days equal 20 hours? Well, you know it's going to be less than 1 because there's 24 hours in a day. But we're going from hours, which is smaller, to days, which is larger. Small to large, we divide. That's right. 20 divided by, what's your conversion factor? How many hours are in a day? 24. Very good. Now, rather than having to divide this out, let's just go ahead and reduce it. The common factor of 20 and 24 is probably going to be 4. 4 goes into 25 times. 4 goes into 24, 6. You have 5/6 of a day. And let's do number 20. Number 20 says, how many weeks equal 40 days? Okay, well, we're starting with days, which is smaller, going to larger. Small to large, we divide. That's right. How many days are in a week? 7. So we're taking 40 divided by 7. There's no, 7's a prime number, so there's no common factor there. 7 goes into 45 times. That's 35 with 5 left over. And so we have 5 and 5/7. 5 and 5/7. What I'd like for you to do now is pause the video and go ahead and work out number 21 and 22. Now that you have unpaused the video, I am going to erase these, and I'd like to show you 21 and 22 before we head to our word problems here. Hopefully those came easy, but there may have been a tricky one for you, which is why I want to do it, okay? All right, so number 21. Oh, I almost put the answer there. How many hours equals 3 1/3 day? So we're going from days to hours. That's small to large, I divide. So 3 1/3 divided by how many days are in an That is my fault. This is why I need students here to correct me. I'm going from days to hours. That's large to small, so I multiply. Very good. So 3 1/3 times how many hours are in a day? 24, that's right. So take this into an improper fraction. 3 times 3 is 9. That's 10 over 3 times 24 over 1. 3 goes into 3 once. 3 goes into 24, 8. 8 times 8, 10 is 80. Very good. So we have 80 hours for number 21. Let's look at 22 finally. How many seconds equal 3 1/3 hour? So we just did 3 1/3 day over here. Now we're doing 3 1/3 hour. Going from hours to second, hour is larger, so we're going from large to small, so we multiply, that's right. And we're going to take 3 1/3, and how many seconds are in an hour? Whoa! Mr. McDonald, that is a little bit tricky. You're absolutely right. So if we're going to go from, if we're going to go to seconds, we've got to find out how many minutes first, and then we can go back into seconds. So really what this problem looks like is so let's take this 2 steps here to get all the way back to seconds. So first of all, we want to turn this into minutes. So we're going to take 3 1/3 because we're going from large to small, so we're multiplying. And we're going to multiply that by 60. 3 times 3 is 9, plus 1 is 10 over 3 times 60 over 1. 3 goes in there once, 3 goes in there 20. This equals 200. So I'm starting with 200 minutes here. Now I can convert that into seconds, okay? I'm going from minutes to seconds, which is large to small, so I multiply. So I'm going to take 200 over 1, and I'm going to multiply it by 60 seconds over 1. I don't really need the fractions anymore, but 200 times 60, we have 3 zeros, and 2 times 6 is 12, so we have 12,000 seconds for our final answer. That was a little bit tricky, but I hope it didn't throw you off too much. Let's turn to page 118. We've got some word problems that we want to do, some word problems we want to go over. And then we will be through with this lesson. I know it's been a little bit longer if you took your quiz already, and if you did those sample problems, but we'll be done here just shortly. Number 1, World War I officially began on July 28th, 1914. The last peace treaty was signed on November 11th, 1918. Approximately how many whole years did the war last? How many days did it last? Well, approximately how many years? You could subtract 1918 minus 1914, and you have an approximate of 4 years. Rounded off to the whole years, but how many days did it last? That answer is a little bit more specific because we have some months that are involved. So really what we need to do is we need to start with our first non-full year, and then our 1915, 1916, 1917 are all full years, and then 1918 we've got to do the month calculation as well, okay? So let's begin to calculate. So basically, we know that July 28th to July 31st, and this is all 1914, okay, is equal to how many days? 3 days. So that's where we're going to start. Then we go to August, September, October, November, and December, okay? Well, how many days in August? Okay, August has 31. What about September? 30. October? 31. November? 30. December? 31. So we can add these up. 3 plus 1 is 4, plus 1 is 5, plus 1 is 6. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So we have 156 days in the year 1914. Well, how many years is 1915 going to have? Well, of course, it's 365. 1916? Well, you probably said 365, but notice 16 is divisible by 4, which means that was a leap year. So how many days? 366. What about 1917? That is 365. So here we come into 1918. We didn't quite get into December. We got actually into November. So we need to go, all right, so we've got January, how many days? 31. February, this one would have been 28. March, we have 31. April, we have 30. May, we have 31. What about June? May, June, we have 30. July, we've got 31. August, 31. September, 30. October, 31. And November, Well, we actually went to, the question says November 11th, so we actually only have 11 days here, okay? So let's add these together. 1 plus 8 is 9, plus 1 is 10, 11, 12, 13, 14, 15. I'm going to put my 5 there and carry my 1. 1 plus 3 is 4, plus 2 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 3 is 21, plus 3 is 24, plus 3 is 27, plus 3 is 30, plus 1 is 31. So we have 315 days there in 1918. So 365, 366, 365, 315. We need to add the 156 from 1914. So let's add all these together. 5 plus 6 is 11. Plus 5 is 16, plus 5 is 21, plus 6 is 27, carry your 2, plus 6 is 8, plus 6 is 14, plus 6 is 20, plus 1 is 21, plus 5 is 26, carry your 2. 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 1 is 15. 1,567 days. What do you think? How was that? All right, that was just number 1. Okay, no, you did a good job on that. I hope that makes sense to you, but that was a long problem. But let's go to number 2 over here. Number 2 says this: Chloe Moore had an emergency appendectomy. She was in the hospital from Monday at 8 p.m. To the following Sunday at 2:15 p.m. How many hours was she in the hospital total? Okay, this one's very similar. On Monday, you'll notice she was there from 8 p.m. to 12. So for Monday, this is number 2. From Monday, she's going to be there for 4 hours. Okay? Tuesday, Wednesday, Thursday, Friday, Saturday, 5 days she was there all day. So that's 24 hours times 5. 4 times 5 is 20. Carry your 2. 2 times 5 is 10. Plus 2 is 12. So we have 120 hours to represent that. And then Sunday, she says she was in the hospital until 2:15. Well, if we start at 12 a.m. to 12 p.m., that's 12 hours. And then plus the 2 hours and 15 minutes. 15 is 1/4. So that's actually 12 for Sunday. It's actually 12 and 1/4 hour. So we need to add these. 4 plus 0 is 4, plus 2 is 6. Bring down your 1/4. And then 1 plus 1 is, 2 plus 1, sorry, this is not lined up very well. 2 plus 1 is 3. Bring down my 1, and I have 130, I'm sorry, yep, you're right, I know you saw it. 14 and 1/2 hours, so that should be 138 and 1/4 hours. I hope you got that. Let's look at number 3. What was the year 1900 a leap year? Remember, if it ends in 2 zeros, it has to be divisible by 400. And if you were to put 1900 over 400, cancel out your zeros. 19 is not divisible by 4, therefore that was not a leap year. Number 4, was the year 1996 a leap year? Well, when it ends in not 2 zeros, take that 2 last digits, 96. Is it divisible by 4? 4 goes into 9 twice. Minus 8 is 1. Bring down my 6. It is divisible by 4, which means on number 4, it is a leap year. Number 5, President Abraham Lincoln in his famous Gettysburg Address said, 7 years ago, our fathers brought forth upon this continent a new nation conceived in liberty and dedicated to the proposition that all men are created equal. The year the United States was established was 1776. When did he give the speech? Okay, well, this is pretty interesting because you guys probably at some point have memorized part of or the whole Gettysburg Address, and so you already know 7 years ago. So what I would like for you to do is to take 7 years ago. Okay, well, how many is 4 of years in years? Well, if we're going from a score of years to years, we're going from something large to something small, so we multiply 4 times, well, how many years are in a score? 20. So this equals 8, but he said 7. So that's 80 plus 7, which equals 87 years. And if we started in 1776, and 87 years later he gave the speech, 6 plus 7 is 13, carry a 1. 1 plus 7 is 8, plus 8 is 16, carry a 1. 1 plus 7 is 8. It was the year 1863, or as we know it, 1863. And number 6, Old Faithful, the famous geyser in Yellowstone National Park, erupts once in every 94 minutes. How many times per day does Old Faithful erupt? Okay, so first of all, we need to find out how many minutes are in one day, because it's saying how many times per day. So how many minutes are in one day? Well, One day, we would have to go to hours. How many hours are in one day? It's 24 hours. So 24 hours equals how many minutes? Okay. Going from hours to minutes, large to small, multiply. Very good. 24 times 60. Bring down my 0. 4 times 6 is 24. Carry your 2. 2 times 6 is 12. Plus 2 is 14. There are 1,440 minutes in one day. It is erupting every 94 minutes. So how many 94-minute units are in 1,440? Of course, I have to divide. Let's divide by 94. 94 cannot go into 114, but it can go into 144 one time. Minus 94. 4 minus 4 is 0. 14 minus 9 is 5. Bring down my 0. Use 9 as my estimator. 9 goes into 50 about 5 times. 5 times 4 is 20. Carry your 2. 5 times 9 is 45. Plus 2 is 47. That leaves me with 30. If I annex a 0, because I do have to round off to the whole, 94, how many times does it go into 300? I would presume 3, so 15.3 times 4 is 12, carry 1. 3 times 9 is 27, plus 1 is 28, that's correct. 3 makes the 15 stay the same, so it is 15 times per day that Old Faithful erupts. How was that? It was a lot of work, wasn't it? Number 1 was a big question. All right, that's all I have for you today. Your homework, though, is Sharpening Skills 1 through 19 on page 118. Don't forget at some point today you need to take quiz 10. If you didn't do it in class, then make sure your proctor does that after. Snap a photo of that, send it off to Mrs. Morrison, and she'll get those graded and be able to go over those next week. If you have any questions about this content, please let me know and let Ms. Morrison know. We'd love to help you out. Other than that, hope you all have a wonderful weekend, and we will see you back here on campus Monday morning, October 19th.